I continue again. On the left, we can see the various options which are Design Manager, E Library, Spice Library, LC Parts, and some other things. So, for if you look at the circuit diagram which I've shown you or which I've drawn on the note which I've shared with you can see that we need a DC source, we need a diode, we need a battery. A DC source is exactly the battery. We need a battery, we need a diode, we need a resistor. Okay, and there are some other connections. Okay, so let's get started. I'll simply go to the EE library. There I can see a wide variety of the products, and here I'll go to the DC source, that is the VDC. First I need to have the DC source, so I place it here. So when you drag a component from here to here, then right click it and leave it like that, and let us zoom it a bit. So this is your V1. Fine. And then after that you need to have a resistor. Let us have a resistor here. So I've placed it here, and to fix it at some position, I need to right click it and then leave it. Okay, so this is my resistor. Then what do I need? I need an ammeter for measuring the current. Now I go to the Spice library because it is not here in the library components which are displayed on the left side. So I go to Spice library and I simply search ammeter. Okay, so I go to the second ammeter because you can see the description, it's a simple ammeter to probe. Okay, so I select it here, I click on it, and I go to the place button, and simply I can place the ammeter wherever I want. Again, the right click. And then I need a diode. Diode can be found from the library, which is here, I guess. Yes. So here we have a diode 1N4148. So I'm taking the diode, I'm placing it here and right clicking. But since I need the orientation of the diode to be such that it becomes forward bias, so I'll select it by left click and then click the letter R on the keyboard. So go on rotating until the desired orientation is, or the position is obtained. So that's it. And now what do we need to do is we need to join all the components. For joining all the components, we need to have the wiring tool. So wiring tools are here along the right hand side, and we go to the selecting the interconnect wire, which is here. So let us start from here, go to here, start here, and stop here. Okay, so it stops here. Then again we start here, connect the ammeter like this, and stop. Stop will be again by the right click. Okay, and then again we select it, we go to the ammeter, we go to the this end of the this, again select it, and then we join the P side of the diode. And now here I again take the wiring tool, I do like this, I stop it here, then I again do it like this. Okay, I stop it here, and then I click it like this. So, and then I need to place the ground. So I am placing the ground connection here. So after placing the ground, the circuit is done. But my ammeter will measure the current which will flow into this circuit, and I need to measure the voltage across the diode. For that, I have to place a voltage probe. Voltage probe can be found from the wiring tools on the right hand side. So click on to the voltage probe and place it here. Okay, so again right click and the voltage probe will be placed. Now the name of the voltage probe is VOL probe 1. I'll change it by double clicking onto it, and then I'll name it as VD, which will measure the voltage across the diode. Okay, so you can see now it has been changed to VD. And this is justified that this voltage probe will measure the voltage between the diode and the ground, because you can see that one part of the diode, that is the P side, is connected to the circuit, to the upper part of the circuit, whereas the N side is connected to the ground. So this voltage probe measures the voltage between the P side with respect to the ground. So obviously it is the voltage across the diode. Now you'll see that V1 is 1 volts, has a value of 1 volts, but we'll make it variable. Okay, we'll make it variable by changing the simulation setting. So this is all about the circuit, and our circuit is ready to be simulated. So what do we need to do is that before we go for the simulation, we need to save it. Go to the file and go to save, because you have already created a project for this experiment. This experiment will be saved into your project, which is the diode underscore part 1. Okay, now next we go to the simulation. Before we run the simulation, we can see that there are three options, that is run your simulation, simulation setting, and show your simulation report. So we'll not go to the run your simulation first. We'll go to the simulation setting, and when we go to the simulation setting, what we'll do is we'll go to the there are four options, that is transient analysis, that is if you want to vary the parameters with respect to the time and see the behavior of circuits with respect to the time, or AC analysis. Okay, DC sweep, here you do not want to have the AC analysis because you're not using the AC sources, any of the AC sources are not used, but you're using the DC voltage. So DC sweep we require. Source to sweep, what is the source which we need to sweep is the input source which we have used, that is the V1. So we name it as V1. Start value I need to have, start value will be 0, stop value will be, let me say 1, because we know that the knee voltage of the diode, whether it is silicon or whether it is germanium, it is much lesser than 1, and since we are using 1 in 4148, that is a silicon diode, and the increment is to be 0.1. Okay, so let us go to this and see what is DC transfer. We do not need this, we do not need this. DC sweep is okay, and let us run it and see what we'll get. So on the other window, you can see now a waveform window has opened, and we see two parameters here, that is the VD, that is the diode voltage, which is shown in blue, and the current which flows into the diode, because the diode is in series in the circuit. So the current which will flow in the series will be the current flowing across the diode, flowing into the diode rather. So this orange one is the current, and you can see that the current is starting from 0, and it is showing a very steep increase or exponential increase only after a value of, you can see it here, it is around 0.5 volts, because it's 502 millivolts, so it is around 0.5 volts. Or if we want to further refine it, and you can see here, this is the voltage across the diode, or here, yeah, where this is increased, so this is around 0.6 volts. So if you want to further refine it, what we need to do is we go to the simulation again, go to the simulation setting again, and increment it only by 0.05. If you want to have a finer graph, again run it, you'll get another waveform. Okay, now you can see that here you have now a smoother waveform like this. Okay, so this is your current, which is in the orange one, and this one is your voltage, that is the VD. Or else since we are directly varying the voltage V1 from 0 to 1 volts and with a step of 0.05, so you can easily see that the current flowing into the diode rises exponentially only after the knee voltage, which you can find out from here. So it is around 500 millivolts. So that is what is about the forward characteristics. And uh, I've already done this also, so maybe there are some changes into the circuit parameters, or maybe you can change some of the values. This is the circuit which I have already simulated, and I've also got the same waveforms. This waveform I got when I took the steps, I kept the step size as 0.1 volts. And the another waveform which I got was when I kept the waveform as 0.05, the same which I have already shown you. Now, using the same window, let me show you that if we increase the value of R, for example, we are increasing the value of R up to 2K, we can change the value of any of the parameter and but before we go to the running the simulation, we need to save if we are making any changes. So simulation and run your simulation. Now we'll get a third waveform. Okay, now you'll notice that there will be a bit of difference. Okay, so we can close this waveform. Your file has not been saved. Do you want to save it? We say yes, we want to save it. Title is actually diode underscore IV, diode IV. Okay, save to an existing project. Okay, so waveform. Let us save it to a waveform. Okay. Now let us do one thing and let us reverse the orientation of the diode and see if we'll be able to see the changes in the current and the voltage, because what we can see is that first it should increase linearly for a smaller portion, and then it should saturate, and when the breakdown is reached, then only it should break down. Let us go to this file, let us save it and go to the simulation and let us see what happens. Okay, so we can see here, you can see that the current here is, so this is the voltage across the diode VD, so forget about it. So you can see that as you're changing the voltage from 0 to 1 volts, in the reverse direction, your diode current is first increasing to a bit, and to a value of 2.5 nanoamperes. Now automatically the current range has changed from the milliamps, which was in the forward biased conditions, you can see, or microamps, you can say. Now it's still 50 microamps, 200 microamps. Now you'll see it's a nanoampere unit. So nanoampere is 10 to the power of -9, so that means it's a very, very small current as compared to the current which we have obtained under the forward biased conditions. So it's like that. So here this current, that is 2.5 nanoamperes, which is your constant current, is the reverse saturation current. Now if you further increase the voltage, maybe the diode will break down. So this is like, we can save it, go to the save as, write IV underscore diode underscore reverse. Okay, save. And similarly, this waveform, you can write file, save as IV underscore diode underscore forward. So this is how the forward and the reverse characteristics of the diode, PN junction diode, can be obtained. Now there's a difference, as I had drawn the circuit onto the notepad using a potentiometer. Here I'm not using a potentiometer now, because when you're using a potentiometer in a circuit, you vary the resistance, and by varying of the resistance, you're varying the voltage which is appearing into the circuit. Now here it's of no use, because you can directly control the source, because in the labs we have a fixed DC source which has a value of, for example, 12 volts or 6 volts. Fine. Uh, then when you need to change its value, as I had changed here from 0 to 1 with a step size of 0.05, there you need to change it by using a potentiometer, because it's a fixed supply provided by the manufacturer. You cannot change it in steps. And then for measuring the voltage and the current, which we are doing here using a voltage probe and an ammeter. In the physical labs, we use the voltmeter and the ammeter if we have, or if we do not have the voltmeter and the ammeter, we can simply use the multimeter. That is the only difference. Fine. So I hope this will be of help to you, and you need to practice it at your own on your own laptops or your mobile phones. I'm not sure whether this easily will work on the mobile phones or not. So for any queries, you can just get